Hey everyone, welcome to Tutoring. Hope you're having a great day. Today we are going to be doing some anti-differentiation basics. For those of you who haven't done methods 3, 4 yet, or if you haven't covered the anti-differentiation topics for methods, for SPECH you will be needing these basics. So it's assumed knowledge, and that's why hopefully this video helps you get a quick understanding of how to anti-differentiate each of these functions that I've listed below. So today we'll be going through 6 different functions and we're going to be anti-deriving each of them. Right, so let's get started. Our first function is the polynomial function. So that's the x to the power of n. So x to the power of 2, x to the power of half, x to the power of negative number, something like that. So that's called a polynomial. How would you anti-differentiate that? Well, this one you just have to think opposite. Whenever you think of anti-differentiation, you think of opposite to differentiation, and it works the same. So let's get into it. How would you anti-differentiate x squared? If you want to anti-differentiate x squared, you add the power by 1. So in that case, 2 plus 1 is 3. And then once you get the new power, you bring it down. Unlike differentiation though, differentiation, you bring it down, you just multiply by it. In anti-differentiation, when you bring it down, you divide by it, okay? So in that case, it's 1 over 3 x cubed. So that solves the first part. On to the second part, I'll just write this in a different format. So root x is x to the power of half. If you want to anti-differentiate that, you apply the same logic, same theory, okay? So x to the power of half, we add the power by 1 first. So make sure you add the power by 1 first. So that's 3 on 2. And then you divide that new power. So 1 divided by 3 on 2, that's the same as 2 over 3. So that is that part done. And then we anti-differentiate 1 over x squared. I'll write this in a different format once again. That's x to the power of negative 2. If you want to anti-differentiate that, well, do the same thing. It's x to the power of negative 2 plus 1, which we get negative 1. But then you bring the negative 1 down. 1 divided by negative 1 is negative 1. So you get minus x to the power of negative 1. And of course, whenever you anti-differentiate something and there's nothing mentioned, you always put a plus c. The reason why we put a plus c is if you were to differentiate all of this back, so over here, the plus c is pretty much a number. So maybe 5, for example. If I differentiate 5, it disappears. Your original function maybe had a 5 to begin with, right? So that's why you have to be careful, okay? So just always put a plus c. Your teacher is going to be ranting about it. It's going to be going through it a lot. So yeah, just don't forget. So that's how you anti-differentiate polynomials. The first step, add power. So add power by 1. And then step number 2, bring new power down. Bring power down, but divide it instead, okay? So that's pretty much the theory, the goal behind it. First step, add power by 1. Second step, bring power down, but you divide, not multiply. So be careful. Right, so that's polynomials all sorted. And let's move on to exponential. So with exponential, if you want to anti-derive exponential, then you keep the power the same, e to the power of 2x, you keep that the same, and then you bring the derivative down. So the derivative of the power. So if you derive 2x over here, that is 2, you'll get 2. But then instead of multiplying by 2, you divide it instead, and you get half e 2x, and always make sure to put plus c. So if I was to derive this, I will derive the power and then bring it down. And of course, if you do that, you'll get e to the power of 2x. But if you're working backwards, you derive the power, you bring it down, but you divide instead. So just always think backward, okay? So that's how you anti-derive exponential. It's quick and easy, nothing too complicated. So I'll show you the steps here. So step number 1, derive the power, and then bring it down, but divide it, okay? So that's pretty much it. And then of course, number 2, leave the exponential alone. So don't touch the exponential, leave it alone, and just derive the power, bring it down. So that's pretty much it for exponential. Just on a side note though, be careful, do not do this. So if you have, for example, e to the power of x squared dx, and you asked to anti-derive that, well, in this course, we actually can't do that, so you can't apply this theory right here. If you were to derive x squared, you get 2x, right? And then you bring the 2x down, but you divide it, so you get 1 over 2x, and then you leave the x squared by itself, and then put a plus c. The problem with this is, if you try deriving this back, right? So if you try to derive this, obviously if you derive something, it should get you back to the original, right? The antiderivative. So if you try to derive though, that's one function, that's another function, you have to use product rule. And whenever you use product rule, you'll end up with two terms and you'll realize that you won't get back to this function. So if you're anti-deriving an exponential with power of x bigger than 1, so any power that is not 1, so it has to be only x to the power of 1, then you can't anti-derive that. In this course, we can't do that. And the only way you can do that is you either use a calculator, or the question is worded in a way that you can anti-derive it by hand, but it's not in this video. I'll go through it in a different video soon. Okay, so do not do this. We do not want to do this. You can only anti-derive something with x to the power of 1. Okay, so that's for exponential. Let's move on to hyperbolas. So how do you anti-derive hyperbolas? Well, think about a function that when you derive, you get a hyperbola. Now just think backwards. If I anti-derive hyperbola, what should I get? And if you studied enough on differentiation, you should know that this is log. So log e mod of x plus 1. If I derive log, I get my hyperbola, which is 1 over, so f dash over fx, right? So if I derive this, I get 1 over fx. Same thing over here. If you were to anti-derive hyperbolas, you get logs. Just to make sure though, if there's a number in front, let's just say there was a 2, then it's the same logic that applies to exponential as well. So you derive the function at the bottom, and then you just multiply it outside, but divide it. Don't multiply it, you divide, or you find the reciprocal of that, okay? So that's the case, and then you put a plus c. So yeah, same logic here. You derive the function on the denominator, and then bring it out, but divide. So same thing here, but divide. And then step number 2, it just becomes a log. So the function becomes a log e of whatever is on the denominator, okay? So that's pretty much it. You leave that the same. If that's 2x plus 1, then you put a 2x plus 1 over here. If it's an x plus 1, you put an x plus 1. And then just make sure to derive the inside function, the denominator, and then bring it out, right? So that's hyperbolas. Should be quick and short. Let's move on to our trigonometry graph. So that's your sine, cosine, and tangent. So deriving sine, think of it opposite. What do I derive to get positive sine? Well, if you think about that, if I derive negative cos, I get positive sine. So in this case, if you were to anti-derive positive sine, you should get negative cos. You keep the function inside the same, so it's cos 3x minus 5 with a negative, but don't forget, just like with exponential, hyperbolas, and later on when we learn about sine and tans, you always multiply by the derivative in the inside, but you reciprocate that, so find the reciprocal of that. So in this case, if I derive the function in the inside, that is 3, but when you bring it out, you divide it. So in that case, times 1 on 3, okay? So it's pretty much the same thing. It's like chain rule, but then instead of multiply by the derivative, you divide by the derivative, and that's it. Always make sure to put plus c, and there we go. So your final answer really should be negative 1 on 3 cos 3x minus 5. Okay, and then plus c. I'll just do cosine because sine and cosine are very similar to each other. Just be careful though, you have to think backwards. So in this case, if I was to anti-derive positive cos, what should I get? Think about the derivative. If I derive positive sine, do I get positive cos or negative cos? Well, if I derive positive sine, I get positive cos. So in that case, if I anti-derive positive cos, I should get positive sine. So in this case, we get sine negative x minus 1. Just put a plus c in there. But once again, you derive the function in the inside and then you bring it out and divide it. So in this case, we derive it here, we get negative 1. The negative 1 here disappears, negative x becomes negative 1. 1 divided by negative 1 is still negative 1, so therefore you get negative sine of negative x minus 1 plus c. So just be careful, don't mix them up. If you want to check if that should be a positive or a negative cos or sine, then just derive your answer. Do you get back to the original? If you don't, then you did something wrong. Then you probably did the opposite sign, so just be careful, okay? So I'll just write it here. Number 1, cos x becomes, so if you anti-derive that, it becomes sine, positive sine. But if you anti-derive sine x, then be careful, that's negative cos, okay? So it's like going opposite of derivative. And then yeah, same logic here, you know, derive the function inside, so derive function inside the trig, bring it out, but divide, okay? And yeah, it's the same logic every time, you'll get over it, okay? On to our last one, so the tangent, and I haven't written a tan x here, I've written the antiderivative of sec squared 2x, and why is that? Because if I derive tan, what do I get? Sec squared. So if I anti-derive sec squared, I should get tan. So in that case, our answer here should be tan. It's the same thing, you leave the function the same, okay? Leave the function the same, but make sure you derive the function in the inside, which we get 2, and you bring it out. But when you bring it out, you divide it, okay? And then put a plus c. The reason why I haven't written the antiderivative of tan x, for example, over here, is you actually can't, there's no way to do it just yet. I'll show you in the next video how to antiderive tan x, but for now, we can't antiderive it just yet, okay, with the basics that we know so far. So when you're antideriving sec squared, you'll get tan. Just be careful, sometimes that's like that one-off question where you overthink it too far, okay? But that's pretty much it for today's video, guys. That is the anti-differentiation crash course for you. If you haven't done the method 3-4, or if you did it and you forgot about how to anti-differentiate all these functions, hopefully this video helps you bring you back up to speed. But aside from that, thank you for watching, and I'll see you in the next video.